So we're going to look at voting in this chapter. I want to stress that when I'm going to do most of the things in here in context of like political voting, voting for a candidate or voting for a bill or a motion to pass or fail or something like that. But voting doesn't just apply in those situations that we think of it most often. It also applies in things like, well, at a track meet, if there's 20 events, how do I determine a team winner? And things of that sort. Now, the easiest situation that comes up in voting is when we have to choose between two different candidates. Now, when I say candidates, typically we think of people, but again, we could think of lots of things, companies to go to, who to hire from, or something like this. So if we vote, basically the easiest situation is we have two candidates, and in that case, basically a majority rule would be the way to vote, meaning the candidate with the most votes wins. All right? It's a nice, simple, straightforward way to do voting. Now, in the two-candidate situation with majority rule, we have some really nice desirable properties. First, all candidates are treated the same, meaning one doesn't get an advantage, one doesn't get a disadvantage. All voters are treated the same. All right, everybody gets the same. Everybody gets one vote, or at least the same number of votes. And we have this third property as well. If any voter switches their vote away from a loser, then the result stays the same. In other words, if I go from if I'm somebody who voted for the losing candidate, if I switch it, then the vote's the exact same after a second vote. All right. Now, these are pretty straightforward properties, right? In almost any situation, you want these three things to happen. You want all candidates to be treated the same, all voters to be treated the same. And, if somebody decides not to vote for a losing candidate, there's no change in the outcome. But it turns out that really only majority rule with two candidates satisfies all three of these properties. Okay? And that's a really interesting idea. That's something called May's theorem. But it tells you that when you have more than two candidates, things get a little bit hairy. And it turns out when there's more than two candidates, there's lots of methods that you could use. And none of them satisfies all sorts of desirable properties. We'll get into that. Obviously, we had these three desirable properties, but we'll get into some more desirable properties that we'll see later.